Exercise 3.19, problem 1 to 5 solution. If the system of equations, that is 6x minus 2y equal to 3, kx minus y equal to 2 has a unique solution, then either k equal to 3 or k is not equal to 3, k equal to 4, or D option D is k not equal to 4. So let's first list out. For a unique solution, a1 by a2 is not equal to b1 by b2. This is the condition for unique solution. Or if you cross multiply, what will happen? It will be a1 b2 is not equal to a2 b1. This is the condition for unique solution. And the equation must be in the standard form, ax plus by plus c equal to 0. So the first thing is that we'll have to identify a1, b1 and c1, a2, b2 and c2, and put it in one of these equations and simplify it and get the value of k. Okay, this is how this problem needs to be worked. So now let's get going. So what is a1 in this case? a1 is 6. Okay, ax plus by plus c, right? This 3 has to come this side, right? But anyway, a1 and b1 is only used, so we don't need to worry about the c. So a1 is 6, b1 is minus 2, a2 is k, and b2 is minus 1. So that is what we have listed it out here. Okay, so now apply that in this equation. So what will happen? You will get, okay, I'm trying to do by this method. So a1 by a2 is not equal to b1 by b2. a1 is 6 divided by a2 is k is not equal to b1, right? b1 is minus 2. So minus 2 divided by minus 1, that is b2. So 6 by k is not equal to minus 2 by 1. Okay, so you can multiply. So this will be 6 into minus 1 is not equal to k into minus 2, right? So this will happen. 6 into minus 1 is minus 6 is not equal to minus 2k, right? Or k is not equal to 3. Okay, and the other way is you can apply this formula also. a1 b2 is not equal to a2 b1. a1 is 6 and b2 is minus 1, right? b2 is minus 1 is not equal to k, which is a2 b1. So k into minus 2, and this minus sign will get cancelled. So 6 will be not equal to 2k, or k will not be equal to 3. So either way you'll be able to work it out. I prefer this method, that is using this equation is much easier, because this cross multiplication, other things comes into play. This is straightforward. So apply this. a1 b2 is not equal to a2 b1. So k is not equal to 3. So the option for us is basically option B. K is not equal to 3 is the condition for unique solution. Okay. All right. Next, we'll go to the next problem. A system of two linear equations in two variables is inconsistent if their graphs, okay, coincide, intersect only at one point, do not intersect at any point, cut the x-axis. So this is straightforward. A system of linear equation is inconsistent if there is no value of x and y that satisfy the equation. In such case, the graphs will not intersect at any point. See, they don't have any common point at all, so they are inconsistent. Okay, so that is the key here. So they will not intersect at any point. If they intersect at any point, then there is one value of x and y which will satisfy both the conditions, both the equations. Since they do not intersect each other, there is no value of x and y which will satisfy both the equations. Okay, so this is so in this case do not intersect at any point. So this is basically option C. Okay, next we'll go to problem 3. The system of equations x minus 4y equal to 8 and 3x minus 12y equal to 24 has infinitely many solutions, has no solution, has a unique solution, may or may not have a solution. If you look at it, this equation is multiplied by 3 to get this equation. So the 3 into x is 3x, 3 into minus 4 is minus 12y, 3 into 8 is 24. So the condition for that is a1 by a2 is equal to b1 by b2 equal to c1 by c2. Then the system has infinitely many solutions. Basically, these two lines are parallel. So when they are parallel, then you will have infinite number of solutions, one lying over the other. Not only parallel, they are one lying over the others, in which case there will be multiple points which will prove both the equations, so you will have infinite number of solutions. The condition for that is a1 by a2 equal to b1 by b2 equal to c1 by c2. So let's check it out. So here a1 by a2, that is a1 is 1 and a2 is 2, so it's 1 by 3 equal to minus 4 by minus 12, that is b1 by b2. b1 is minus 4 and b2 is minus 12, so minus 4 by minus 12. Okay, that is basically 1 by 3. So 1 by 3 equal to 1 by 3, and c1 by c2, see that is actually it will become minus 8, but minus 8 divided by minus 24, but minus 8 by minus 24 will actually 8 by 24, that minus and minus will get cancelled, and 8 by 24 is also 1 by 3. So all three, a1 by a2, b1 by b2, c1 by c2, all points to 1 by 3. Therefore, they are all equal, and since they are equal, the system will have infinitely many solutions. So the option for us is option A. Am I right? Okay, let's move to the next problem. If 1, 0 of the polynomial p of x equal to k plus 4 the whole x square plus 13x plus 3k is reciprocal of the other, then k is equal to. So basically, when the roots are reciprocal, let the roots are x and 1 by x. So what happens? And the product of the roots will be equal to 1. So what is the product of the roots? That is c by a for a quadratic expression. This is ax square plus bx plus c. Am I right? So c is 3 and a is k plus 4. So you'll have to compare this equation with ax square plus bx plus c. So the a is a k plus 4, b is 13 and 3 is c. 3k is c, I'm sorry. And since the roots are reciprocal, what happens? Let's say the roots are x and 1 by x. So the product of the roots will be x into 1 by a. So x and x will get cancelled. That will be equal to 1. Therefore, the product of the roots is equal to 1. In which case, what is the product of the roots? C by a, right? That is our formula. So 3k divided by k plus 4 will be equal to 1. Now you cross multiply, you will get 3k will be equal to 1 into k plus 4, or this k will come this side. So you will get 2k equal to 4, or k will be equal to 2. So this is the value of k for which the roots are reciprocal. So k equal to 2 is this option. So basically, we have A. Okay, so the key point is they have told that it's reciprocal, and since they are reciprocal, the product of the roots is equal to c by a equal to 1. So that is a condition which we are using. Okay, right. Next we'll go to the problem 5. The sum of those two zeros of the polynomial f of x equal to 2x square plus p plus 3x plus 3k is 0, then the value of p is sum of the two zeros is 0. So what is the sum of the two zeros is minus b by a. Am I right? So a is 2 here, b is p plus 3 and c is 3. Right? So minus b by a is the sum of the roots, and that is equal to 0. So what we need to do is minus of p plus 3 divided by a, that is 2, is equal to 0. Okay, this is our formula. So we identify a and b, substitute that, and it's also told the sum of the roots is 0. Am I right? The sum of the roots is 0 is given here. If you want, you can underline that is 0. Right? The sum of the two zeros. Right? So, and the sum of the two zeros is minus b by a. So it's minus of p plus 3 by 2 equal to 0. So now you cross multiply, this will become 0. So minus of p plus 3 will be 0, or p plus 3 will be 0, or p will be equal to minus 3. Right? So the option is option C. So this is how these 5 problems are solved. If you have understood it, it's great. If not, please go through this one more time. It will become clear. Thanks for watching this video.